All right, I'm going to do some compiler stuff today. So there's some basic things that you want to do all the time in a program, especially a low-level program. You want to set memory to some value. You want to compare a region of memory to another memory, or you want to copy memory from one place to another. And, well, when we first started booting up the compiler, we just used the C standard library for those things. And then in order to reduce dependencies on the C standard library, we wrote like native procedures for these things. But it's not that great to call procedures for these because they happen a lot, and you would rather they get compiled down to the absolute most efficient instruction set on whatever architecture you're running on. And I forget my train of thought there, but I was going to say something else about it. Anyway, so, you know, until now, we've just been calling procedures for these, and they're not even very well, you know, they're just very regular procedures with for loops in them and stuff. And that has some negative effects. So you could say, well, you know, as long as the optimizer is in place and running really well, maybe these optimize to something pretty good, and maybe they do, but probably not as good as if they were built into the compiler, and that takes time. And if you're going to run a debug build, then you could very easily get very sad because the optimizer obviously won't kick in on any of these. So in a debug build, if you call like memset or memcpy, it takes a disproportionate amount of time to what you would like, and there's usually not much point in debugging those routines. So we're going to build them into the compiler today, and we're going to call them intrinsics because that's generally what you call machine-specific instructions. These are going to be intrinsics that map to different things on whatever platform you're on. But they're going to be, okay, so point number one is they're going to be explicitly marked as intrinsics in this preload file. It's not going to be a magical thing like C++ compilers sometimes. Like memcpy was originally just a procedure, right? And now C++ compilers like magically substitute for memcpy. And we don't want to magically substitute. We only want to generate weird instructions for things that are marked to generate weird instructions. And so we're going to make stuff. I'm going to start programming these intrinsics. They're only going to work in the x64 backend initially because I don't do LLVM backend stuff. So we're not going to directly switch all these over, but we're going to do like a thing. We're going to call it memcpy, right, at first, and then memcomp and memset, and we'll just make sure these work. And then when we get them working in the LLVM backend, which somebody else on the team will probably do, then we'll switch all the code over to using all of them. But for now, the goal is going to be to make these work and to write a program that uses them successfully. Now, this doesn't even parse right now. So the very first step is going to be to make this parse, because if I try to compile now, let's try to build Sokoban. It doesn't even know that directive. So that gives us a starting point. I've been rambling a little bit because I literally haven't thought about this for months, but I figured it was time to finally sit down and do it. Does anyone have questions about anything I've said so far? Questions? These are not necessarily going to be the real names of the procedures either. These are like the C library names, and we may want to change them to things that are more readable or that fit into some grander scheme of things or whatever. Anyway, so we're doing this right now so that it looks like a procedure call in regular code to call one of these. And in fact, these will overload with procedures if you want to. It's just that, you know, this means the compiler generates the code 100% of the time. Now, we do have other things that are kind of like intrinsic. Like we have this thing called tagged compiler. Eventually, we want to make these intrinsics. Yeah, see these? So compiler means something a little bit like intrinsic, but what it means is that there's a version of this in the runtime library that compiles the native code, but if it's running in the compiler can swap in its own private interpretation of these. I think we want to leave intrinsic as being a separate thing rather than overloading compiler, although that's just syntactical. We could change that later if we want. Does that mean we can target anything LLVM targets? Well, it's unclear what that means. We haven't experimented with that yet. Is the intrinsic directive implemented? Well, obviously not. You believe memcpy compiles to something close to F348A4. Well, you also have to put the values in the right registers. Can compile time code use intrinsics? So what's going to happen is, for now, we're going to build, so we interpret bytecode at compile time. So for now, we're going to have to build a compiler side implementation of these, and it'll be pretty trivial. It'll just call the C library versions of it. That starts getting really hairy. So for this kind of intrinsic, this is fine, but once you start doing intrinsics that have like locking instructions or just very CPU specific things, it's unclear that that's even going to work or be practical or be performant. So we may eventually, once we start doing like serious SIMD intrinsic stuff, because we want that to work at compile time as well as runtime. Why is my phone ringing? We may eventually have to, instead of running bytecode, we may eventually have to compile to machine code and run that at compile time, which will be a substantial switchover. So I don't want to do it yet. Frickin' people calling me while I'm trying to stream. Is software engineering really engineering? Not usually, no. Will these be safer than the C versions? No, they will not. Are we going to have something like inline assembly, or will you have a link with a library for general assembly optimizations? I don't know what you mean by link with a library for assembly optimizations. I don't understand that. What do you mean there? Be more specific, please. Wouldn't it be better to have a library handle intrinsic stuff such as memory allocation instead of baking intrinsic into the compiler? You're kind of making the compiler platform dependent. No. Well, first, wait, what? Memory allocation? That is not an intrinsic, first of all. So I don't understand that. What? The whole point of what we're trying to do is that we don't have to call into a library to do this. So when you say, wouldn't it be better to have a library handle intrinsics, what do you mean? What is your proposed mechanism by which a library would handle intrinsics? Do I have any tips on code hierarchy in game engines? And that's off topic. We're talking about compiler stuff. If you want a safe but slow memcpy, you can write that just fine. You just mean if you want to have tight loop optimization, will you be able to do that? I don't doesn't every compiler have loop optimization? And what does that have to do with memory allocation? I don't understand. I don't understand any of that question. It sounds to me like a question that's being asked enthusiastically without completely understanding how compilers work, I guess. Okay, so let's make this parse first of all. And that should be easy. We're going to go to where we see compiler, right? When we see this compiler directive, we say, oh, it's compile time. And so we're going to make another flag that says it's an intrinsic. Hopefully we haven't run out of flags. I searched for like repeat directives. Maybe I don't know if it's worth doing that. Maybe we just let you put multiple. Like, I just want to remove some complexity. Yeah, it's like I'm setting a variable. Let's not do that. Let's do this. Because we're setting this right here, so we don't need a separate variable. Okay. So we'll just copy that control. I don't know why I'm bothering to check this. It might be better to get rid of it, but okay, so we flag it. And down here, we let you set foreign function name. I don't think we do that on intrinsic because there's no. Yeah, I don't think we do that. I don't know if we ever even use that, honestly. Okay. So we just set that flag. Geez, it's been so long since I've done this, I don't even remember what header file this is in. It's in here. Yeah. So we need a flag here. Eight with 5 zeros. 5 zeros. Okay. So let's see what happens. Okay. So, procedure is missing its body. Right. So we have to do that next. Okay. I don't know why I'm bothering to check this, but I am. Okay. Hey, we compile. Oh, I haven't run this game in a long time. We probably have to compile some textures. Processing assets. Blah, 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 blah. Yeah, let's not wait for all that. Anyway, it works. So, well, we want to make a test program that calls these things. And then when we compile that, we'll get some kind of internal compile error because it doesn't know what to do when things are flagged intrinsic. Let's just make a foo. Look, we've got a foo. Let's compile our empty foo. Okay, great. Great, it doesn't do anything. Just making sure that we work. Okay, so now we're going to go to our preload. We're going to say n is like 20, I don't know. They're going to say A is n u8, B is n u8. These are just 3 buffers. And we're going to say memset except I memset, right? Do we have print bytes in BASIC? I know I have a print bytes somewhere. Maybe it's not. Print bytes, it's in WAV file or in basic print. The one in WAV file must be debugging. Print bytes. All right. Going to do this for A, B, and C. Really dumb. Well, it didn't work. Compiler also didn't give us an error. Obviously, it can't work because we don't know what should happen when we call these. Let's see if the debug compiler gives us an assertion or something. Let's make sure it works when we just say memset, which it should. But it's been a while, so okay, yeah. So it works when we use the actual memset. That's our slow version. So we want to make it work with memset. Let's see if our debug compiler. Yeah, okay. So when we infer a procedure, if it doesn't have a body, we say, well, one of these things must be true, right? And intrinsic is not in here. So that's a place to start, but there's many things that we're going to have to do to get this to work. I think thing number one is let's get it to work. Let's get them all. Let's do a memset, a memcpy, and a memcomp, and we'll get them all to work in compile time code. That's the easiest implementation for each of these because it just, it's just C code that we write in the middle of the compiler, and that'll make sure that all this structure is in place all the way through the compiler end to end to do these things. And once that works, then we do the back end code as well. So what I'm actually going to do is we're going to have our main. See, we're going to run this stuff at compile time. So our main is just going to be that, and we're going to say run compile time code, and compile time code is going to be this, right? So now, well, again, let me do this. So if I do that, oh, it's asserting on this in the frickin' header. It's not, it doesn't even care about this. All right, let's make sure this works. Okay, so now this is running at compile time, right? And then when we run it, it just says great, it doesn't do anything. So we're going to make all of this, and we're going to add some stuff for memcomp and memcpy as well. Why not have a print line? Because I don't. When I say intrinsics, do I mean compiler level intrinsics or CPU level like SSE? I mean both. We're sort of putting those in the same bucket for now. Whether we want to separate them out later or not is unclear. Like you could imagine having some generic intrinsics that try to map to multiple SSE style instruction sets, multiple SIMD instruction sets. How well that will work, I don't know, but it would at least, if you could make that work for at least a limited set of problems, it would reduce the burden that you would have as the programmer on making somewhat fast code in some cases. I don't know if it's worth it. Okay. Well, I mean, we're going to have to take care of this assert, if nothing else. So typer line 5310. See, yeah, if it doesn't have a body, and you know what? We might as well check, like audit for who even talks about lambdas compile time, because it's a lot of places. Yeah. So this is going to be putting the name somewhere that we could find it, without which we're not going to be able to resolve the intrinsic to anything. Okay. This is a weird one. I think this is fine. I'm going to put a note here. Has no use. So this is like, what is the value? Like, you know, you can just use the name of a procedure as an expression, right? What happens if you do that with an intrinsic? Well, you're going to be able to do that at runtime. I don't know why you ever would, but sometimes if you don't allow things like that, then, you know, sometimes people would have to work around things that strangely don't work that they think should, right? So you could compare memcomp to memcpy, for example, and you'd get two different pointers and they would compare to false. Just can't frickin' call them like procedures. Okay. I don't think we use compile time here. Okay, hold on. Let's go bytecode runner line 622. I don't want to lose all this context, so I'm going to the other editor. Okay. I'm just going to do this. If it's compile time or intrinsic, I'm just going to do that. So we're going to have to come back. Oh, no. Actually, we're going to do something different here. We're just going to assert that it's not an intrinsic, because this is like the code for you know, putting arguments on the stack and whatever else the hell needs to happen. And we want to catch that before we don't want to generate any of this code, because then, like, you could generate all this code in the internal representation that looks like a procedure call and then optimize it out later, but then you're doing more work and then undoing it, and that leads to a slow compiler. So what we really want to do is generate different code at the site where you would be generating the code to call a procedure. So if we get here, we're just going to assert, and what this means is, of course, we're going to end up asserting until we do that, which is fine. Oh, whoops. I wanted my find results up. Okay. So call procedure, there again, we're going to assert that it's not an intrinsic. That's still in call procedure. Okay. Here, yeah, this is if you try to submit a code modification to a procedure. So we should forbid that for intrinsics. We're just going to put this, actually, let's just do this. All right. LLVM, we're just going to leave. We're not worried about that for now. So whatever LLVM needs to do, somebody else on the team will do. Okay. This is when we're telling user code information about a procedure. So we're going to want to export this flag here. So that means that here we need to give it a flag. And then, so this is on our side, on the compiler side. Now we also need to go to the user side. Look at all, we don't even, these flags aren't even right anymore. We're not maintaining the flags. Okay, wait, foreign is 1. Compile time is 2. C callback is like 2.0. Dude, we need to get our act together. Okay, hold on. Let's do this. Polymorphic. This DLL export thing, we're probably going to change how that works, but okay. Wait. Type only is 4.0. C callback is down here. Oh my god. So messy indent. Okay, compiler generated. Polymorphic is 4.8. Okay. That was more flailing than we needed. Anyway. So now user code can also refer to these flags correctly. All right. Parser. We check that. That's all fine. That's all fine. Pipes. I don't think we're going to do this. Yeah, we're going to do something else. All right. Foreign procedure doesn't specify which library it's in. That's not us. That we already took care of. Okay. So you can't make main be an intrinsic. That's no good. I mean, we would catch that other ways too, but yeah. So compile time. I mean, if you try to make main be an intrinsic, it won't have a body, and we'll probably catch that anyway. Whatever. Okay. Bytecode call procedure. We'll do another assertion there. It's line 27. Wait, no, not line 20. 1505. Okay, we're asserting it's not an intrinsic. We should not have generated a call for an intrinsic. And same here. Oh, for declaration. Yeah. Okay. Great. Ship it. The witness is taking flack on Twitter with this Epic Games Store debacle. No, it's just a small number of gamers being upset. It's so weird. It's like, did they complain when we were PlayStation Plus last month? No. So what's different between that and the Epic Games Store? Oh, it's people decided to be mad about the Epic Games Store. That's the difference. Oh my God, it's the same thing as PlayStation Plus, people. All right. Okay, we messed up here. What happens if you try to take the address of an intrinsic and store it in a function pointer? Well, by address, so we already took care of that. Like, I mean, we don't quite think about function handles as pointers the same way C does, but yeah, it's what I said earlier on about you'll get a pointer value that is unique for that intrinsic, but it won't be meaningful. Like, you can't call it at runtime, but you could compare it to another intrinsic, for example. Do I think gamers would have a right to be angry if my next game was exclusive to Epic Store? No. Why are they? Yeah, like, if you start going down that path, then, like, do other people have the right to force you to do what they want you to do or not? No, because we want to live in a free society. So, I mean, people have the right to express that they would rather you have done something else, that's totally fine. But like, they don't have a right to any developer doing so. People just don't understand how hard it is to make games, and most developers are on the verge of going out of business all the time. If there are deals that help keep developers in business, that's good for gamers, because gamers will have more games to play. So that's all I'm saying. What happens if you try to call the function pointer, runtime crash? Yes. Well, I mean, it's essentially an arbitrary pointer. So maybe you could happen to call a procedure that's actually mapped to the same memory, but the chances of that are very low, and it would probably change every run. So no, you don't really want to be doing that. Reddit says games should be cheaper. But that's what Epic Games Store is trying to do. Because the developer gets a higher cut, they can make the prices lower than they are on Steam. If Steam, I don't know. I don't even know what... I imagine people are going to try to force price parity agreements or whatever. But, like, dude, if you want games to be cheaper, don't get mad at Epic Store. Doesn't make any sense. Doesn't make any sense. All right. They still don't have an option to throttle downloads. Yeah, I'm sure they'll do all that stuff. Okay. Well, so we now, the compiler compiles. I imagine that now we'll get an assertion still, because like, so if nothing else, we'll get an assertion when we try to generate code for a procedure call, because we added those assertions in. We might even get an earlier one because we failed to handle everything correctly. Okay, run instruction. There we go. Remember when we asserted it's not an intrinsic, so that tripped. So now, when we emit the bytecode for call procedure, instead of doing that, we need to take an alternative path where we generate new bytecode instructions. So we're going to need bytecode instructions representing the intrinsics. I actually wonder, how we're going to fit this into our bytecode structs. Anyway. So like memcpy, does memcpy return a value? Let's critically. So here we don't return anything. I don't remember if the C version returns of the pointer or something, but we're not going to do that. Memset doesn't return anything, and memcomp returns the difference in value, which doesn't make that much sense, honestly. I don't know if we're going to want our like, you ideally would like to know like how many bytes in is the difference. Right? There's no reason to stick exactly to C semantics. I mean, we can do that for now because we're just getting this stuff put into the compiler and working. But you know, like we really want what's best. So we want to keep an open mind about all these things. And C memcpy returns the pointer to dest. Yeah, so we're not going to bother doing that. Okay. So here we're going to add okay. So if we ever want to know what the first intrinsic is, like if we want to ask if something's an intrinsic or not, we're going to say, is the instruction greater than the first intrinsic or whatever? Okay. Well, we may want highly specialized intrinsics. Like, see, I'm not sure what these should look like in this instruction set eventually, because, for example, if you memset a fixed number of bytes, right, like that's known at compile time, then you could emit one sequence of instructions. And if you emit, if it needs to be variable at compile time, then you by necessity need to do something slower a little bit. For now, we're just going to do the variable version when we emit the machine code. But like you want the ability to do that later. And I don't know if we would have different intrinsics like memset with a constant length and maybe even constant byte value. Or I feel like maybe not. I feel like maybe the way to do it is when we emit the arguments, we would have a way as flagging them constant, and then the bytecode intrinsic could do a very quick check to see if it's constant. I think that's better, but we're not going to worry about it yet. Just thinking in advance about these things. All right, so we've got these. Okay, we have some names here that get initialized at some point. There we go. Memset, memcpy, memcomp. Okay. Okay. Whoops. C122. What? Come on. What makes a function a candidate for a compiler intrinsic? If it's a very simple, well-defined task that many, many people are going to want to do, and where it's very helpful to have a very short sequence of instructions generated in an optimal way for whatever your target platform is. Okay. Great. So we just added some enums. That's obviously not going to affect what our code is actually doing yet. We need to go to init code for procedure call. Okay. Okay, so at this point, this is the thing that does all this. So if how do I get to these? Oh, it's there. So here's the thing about compilers. Like, okay, we're going to do intrinsics or regular procedure call. This if statement makes our compiler slower every time we generate a procedure call, right? This is like, you don't get away from this. Like, the more features that you add, the slower your compiler gets. It's really just tragic. Okay. So for intrinsic, oh God, I have to think about all these things. All right. Okay. So we're going to assert that this was a frickin' Lambda procedure. Well, let's just see. Okay, so we have a name, and I'm just going to be super dumb about this. Memcomp, memset, site, comma, error, unknown intrinsic with name. That's great. is not yet implemented. Okay, so that's great. Ship it. Incomplete. memset is not yet implemented. Great. We're done. Ship it. Okay. So now we need to put things into the bytecode instructions. And the way these work is we have these 3 slots and they're 4 bytes each, which is fine. Okay. So memcpy. Well, okay, which one are we using in foo? We'll just do that one at first. Memset. Okay. So we have 3 arguments. Oh, by the way, because we went through all our regular procedure sorting stuff, you could like pass arguments by name out of order and all that. So let's do that. But not yet. We got to make it work first. Okay, so we're going to go instruction, bytecode, intrinsic, memset. Well, we'll just have them be in the same order as they are in C for now. So we're going to say dest register value register length. And so we're going to sort of emit loads for all these registers for now because we don't know if they're constant or not. But then in principle, these could be optimized out in the back end. I don't know. We'll think about that. But we want to be able to handle all these cases. Okay, so we need to emit code for expression. Why are we taking the address of that? That's weird. It's because hardened procedure call did. Why is this? It doesn't, okay, that doesn't make sense. This is very old. I guess that could be a const reference or whatever. Okay, we're not going to worry about it for now. Okay. We'll do it for now. You know what? We're just going to do it. It's a sidetrack. It'll just make it slightly nicer that we could say that. Okay. Okay, bro. Now, go back to this for intrinsic. So we just do this, argument list sub 0, the value of the length. Okay, assert argument list dot items is equal to 3. Procedure definition, expression. Oh. Frickin' C++, you gotta do it twice. The language so nice, you gotta do everything twice. Okay, so now I think what'll happen is, because we're running this as compile time code, we'll get to a point where it says, hey, we're trying to run an instruction that's not defined. We don't know what it is, because we should be emitting this memset bytecode instruction, but our runtime interpreter doesn't know what to do with that yet, right? So there we go. Unhandled bytecode instruction intrinsic memset. So I'm going to grab a new T, and then we will resume, and we'll make this actually work now. Does anyone have questions about what's going on? Questions? Questions? No questions. Nobody cares. Nobody cares what we're doing. How's compilation speed been going? I haven't worked on it. We made it go faster, and then we did something that makes it go slower that's fixable, that we haven't fixed yet. Why should they be intrinsics instead of normal procedure calls? Because the whole point is they're more efficient than normal procedure calls. That's the whole point. The whole point is that you're not calling a procedure. You may have learned in college that you should call procedures for everything. That is not true. It is not true. What are the remaining differences between compile time code and normal code? I don't know what you mean by remaining. They're just, what do you mean by differences? Obviously, they're implemented differently in the back end completely. So I'm not sure what you're asking. How bespoke is the knowledge in my project? I don't know how to answer that. How is module stuff going? It's going fine. We've been working on the game mostly. So the module stuff got to a certain point and it's just waiting for me to do the rest of it. What do I mean by intrinsics in this context? I just explained that. You can go watch earlier in the stream. Will you be able to rewire the output of the parser AST and write your own backend for Game Boy dev? I mean, you could in principle, but it would be a lot of work to do it that way. Like, if I were doing that, I would rather do it by actually expanding the compiler. But you could do it that way if you wanted to. Okay. Well, let's do this. So we've got to go to bytecode runner, and there's this giant procedure that does everything. Right? So this is our error that we just had. And so we're just going to assert on those for now. Okay, so we've got an intrinsic for memset. We're going to grab the 3 elements out that we put in, and then we're just going to do it. So how do we do this stuff here? Yeah. It's index A, index B, and results. So we're going to say equals BC index A dot pointer. Oh no. Right. We need, these are register indices. Okay. Let's just copy these out from here. Dest register, value register, length register. Index A, index B. All right, let's make sure that's right. Yeah, AB result is the order. Okay, so we're going to get these, and then we're going to say dest is record registers BC index A. That's a pointer. Value is going to be, whoops. Yeah, let's just, instead of making these names, we'll just go straight to here. Value is U8. Length, what did we define length as? S64. We don't have room for in the bytecode instruction. Oh no, never. I keep getting confused. No, we're not storing the S64. We're fine. This is fine. No, this is all good. Never mind. Let's call it count. Okay, we're getting rid of these. Okay, and we're going to say memset dest value count return. Very easy. This is, of course, this is just the runtime, so we're just calling to the C library to do it. In the x64 backend, we will have to emit instructions to do it. All right. Unknown instruction in x64 converter. Okay. So the reason we're hitting this is because even though, let's go back to our program. So what's happened is we actually ran this at compile time correctly. You can see that we did because we outputted the bytes for A, B, and C. The problem is the compiler doesn't really know that we're not also going to do this at runtime. So it's then trying to compile the x64 code, even though our whole point was to not need that yet. So it's getting later in the pipeline, and it's like, we better output the native code version of this compile time code procedure. There's no way to mark things as not existing in the final executable right now. We might do that later, but we don't have that right now. So what we're going to do is we're going to go here, and we're just going to put in placeholder like warnings for now. We're going to say for these, bytecode intrinsic mem, correct, port warning site incomplete intrinsic. We're not going to stop compilation because we just want things to work for now while we're getting things in place. Site, we don't have site. What do we have? Lambda. Doesn't really matter because we're going to get rid of those later. Okay. So now we're saying incomplete on these intrinsics. That's fine. We're hitting another assertion. Emit code for function declaration. That's weird. I thought we wouldn't hit that. This is weird. It's trying to do code for these specifically. I just don't understand. I guess we're emitting global symbols into the data segment for these. We're just going to have to audit that later. Right. Is intrinsics a keyword? I don't think so. Let's find out. Okay. I don't feel like we should be calling that at all for constant symbols, but we are. So, okay, well, we got a... Great, it doesn't do anything, but it does do stuff at compile time. This is good. So our compile time memset is working, and we know it's working. So let's prove that it's using our version by going into bytecode runner here. And we're just going to say value is CC, right? So all of our memsets now, instead of 0, 0, and F, they should all come out to CC, unless I did something wrong. Yep, they did, CC. Okay, so we're calling our intrinsic in the bytecode version, right? Okay, let's do bytecode versions for all three of these now. And then we can make our code do more stuff. Then we need to do something to return the value. I'm not going to... worry about that yet. So memcpy, we're going to go dest source count. All right. This is a pointer. This is a pointer. And then, so how do I return a value here? Dot S16 is like that. Okay, so we will compile, but these won't ever get called yet because we're not generating the internal representation of these things. So we've got to go back here where we said is not yet implemented and do that, right? So we're going to assert that the num items is 3 for all of these. And memcomp, mem A register, mem B register, count register. Let's call it, let's be consistent in our terminology. Okay. And then mem B is argument list 1. And then here it's going to be whoops. argument list 1. Okay. Source count. All right. Well, maybe that is what it is. Not all control paths return a value. So memcpy returns nothing. Oh, geez. Okay, we have a little bit of a issue. We're going to have to use our extra slot on the bytecode because the thing is memcomp returns a value. So we want to allocate an S16 register. And then we're going to put this in options, which is like our extra thing. I don't use this too often. Yeah, so it's just another int slot. Our bytecode struct is big and fat. We need to fix it. All right. Options is count register. So we need to go back to here for memcomp. This is options. Okay. Great. Not all control paths return a value. That was my whole point. Okay. So now we can make our program do more things. How many registers does it have? Infinite. It has as many as you can run and not die. Okay, so we're back to zeros and F's here. Let's make our foo program do some more things. We're going to have D memcpy d.data c.data n, right? And then D let's screw around with this. Right, we wanted to do this memset with different whatever. So we're going to say so we're using named arguments because we can. Argument name dest. Oh, we're calling it underscore? Let's not do that. All right. Great, it doesn't do anything. So, okay, here we go. So our memset worked, you know, because we used named arguments to put things in different slots. See, we're starting to get the good part. Like we had to plug this into the rest of the compiler, which was annoying. But we get the good part of that, which is that all of our function overloading and value sorting and all that just works. So this works. All the various hybrids of named and non-named will work correctly and all that stuff. And then here we did a memcpy and that worked, right? So then we're going to say comp AD is memcomp A data, D data, and comp CD is memcomp C dot data, D dot data, and okay. So comp AD is minus 255, right? Because you get A minus D, right? Comp CD is 0 because they match. So these work, at least to a very first glance, in bytecode. They don't work in machine code yet because we haven't done them. If I should be using I. Oh, whoops. You are correct. Oh my God. All right. I should be using the I versions. Thank you for catching that. I should have been suspicious because the number of incompletes here should be 1 for each of these, and we were still only getting 3. So there's a fourth one. Okay, that still worked. This should be all I whatever. Thank you. All right. Okay, memcomp is broken. The copy is correct and set is correct because we're using copy to do this. But comp is not working. It's maybe not returning its value correctly. Let's see what happens there. We don't have lambda. Let's just do printf. This is a temporary debugging. So we're just printing out the result. So I'm not sure why it's -1 instead of minus 255. Are we passing the things in the wrong order? Or are we sign extending in some weird way? Are these like signed bytes in the cmemcomp? That's annoying. I'd rather have them be unsigned. See, the thing is we don't want different implementations or different semantics. Oh, I don't want that. That's a garbage. What kind of documentation, if evaluated as unsigned char values? Okay. So supposedly they're unsigned. So then why is the result -1? That doesn't make any sense. I think this documentation is not right. Oh, I see. It's not returning the actual difference. It's just less than 0, 0, or greater than 0. Okay. They're not returning. Okay, that's fine. I mean, it's not that great. I'd rather have a more tightly specified thing. But this is just giving you an output that you could put into a sorting function that doesn't care. All right. Whatever. We'll get picky about what the semantics are later. For now, we're just going to say it's like C, where you get some value less than 0, some value greater than 0, or 0. I don't really like that. I don't see why you would want something that vague, but whatever. We'll do another pass on that later to define it better. Okay, so we're not correctly let's clear out this value. Like, I don't think we need to clear out the whole integer value, but we're going to do that. And let's check for memcomp. We say result register is in S16. And we return the result register. That, in theory, should be what we need to do. Didn't matter. What am I doing wrong? Well, what we're doing is we're not we're supposed to use this result register base. I see. We're not supposed to allocate a new register because we're returning. We already allocated registers, and we're going to use those. Let's see. How do we use those in hardened procedure call? It's called return register base. How do we set the types on those? I guess they already get set by the procedure calling mechanism. So we're just going to do that. Hey, it worked. Okay. Great, it doesn't do anything. So this is all good. We now need to make it so that this all works in x64. So we're going to want 0 of these incomplete intrinsics by the time that we're done. And then we can try actually calling this at runtime. Is there a CPU intrinsic instruction set for memcomp? There is a Sentinel optimization for memcpy that remove iteration checks that I could see being used for null terminated string. What? We don't care about any of that. Iteration check, what? Yeah, that's the C runtime result. And it's a little bit ill-defined. I'm actually going to put something in the header file. Incomplete. The C spec for this routine sucks. We should probably... Okay, whatever. I've vented into the comments. Did I read the Kotaku article on Anthem? No, I heard about it. The thing you have to realize about all these articles is they're all just like, hey, a couple of employees out of 400 got mad and wrote to the writer, and you know, it's one side of a story, and it's a side given to you by people with a grudge. Like, why you would pay much attention to that, I don't know, honestly. Okay, so we want to go to these. Okay, we have a STASB, so we can use this, except not quite the same. In fact, we already sort of have we already sort of have some hard-coded memory clear to zeros, which we could like use. I don't know. We can think about how hard we want to work on that. But for now, we're just going to make it be a separate thing. So right now we're always putting 0 into A. We're putting, well, let's go back and see what, because these probably come in a different order or whatever. So the destination is index A. It's totally different order than this other one. The value is index B. This is okay. So here we need to put into RAX. We need to say do we not have a move 8? I guess we'll use move 64. So right now I believe we give it a full 8 bytes on the stack, which is annoying, but it's the kind of thing we optimize later. Okay. We have no idea if this is actually going to work at runtime. And let's actually, because we're not calling it yet, let's actually put some things in here. So we actually already have a copy memory as well, a bytecode instruction, so we can plagiarize from that. In fact, you might think, why did you make totally separate things for these? And the answer is, dude, I don't know. Maybe I shouldn't have. In fact, honestly, this might have been not the right way to do it. I mean, some of the structure that we did is fine, but like instead of adding new bytecode instructions for these, maybe I should have just done these. Because, so what I was thinking originally was like, hey, the optimizations that we do, like for fixed sizes and whatever, may matter, but we're going to want those for all of these things. You know what? Here's what we're going to do. We're going to leave intrinsic memcomp because we need that. We don't have a memcomp in here. But we're actually just going to use this and this other thing. So you know what? Sometimes we do things one way. Sometimes we do it the other way. So we're going to get rid of those. So we're going to get rid of these two, and then when generating those, we're just going to generate the other instruction. So oh, this is I've made a mistake. This one has a hard-coded constant size. Because that's all the compiler ever needs. So, yeah, you know what? I got to undo everything I just did. Right, and the memset only does 0. Whoops. Okay, we really do need these. Sometimes you delete things that you actually need. Okay. Well, who knows if I totally destroyed everything. All right. So we're back to the way we were doing it. We undid it, and then we anti-undid it. Okay, where were we? actually don't know if this works for large values. We're going to have to look that up. Memset, memcpy. So memcomp is our one incomplete intrinsic right now. I actually don't know how to do memcomp. There must be like a rep for it or something. Does anyone know? Anyone know what I should look up? Or maybe we don't care to do an intrinsic for memcomp right now. Rep comp SD. Okay. So let's we're going to go to the place where all these funny names are defined. So copy memory is going to be STOSD, right? Whoops. Instructions. Okay. So here we go. We're going to say compare I assume it's the same thing. So this is a rep. This is a wide instruction prefix thing. And does anyone know what comp SB is? I'm looking it up. Comp SB A6. I'm just assuming it's the same. Let's look. Compare byte at RSI with byte at RDI. The status flags are set accordingly. I don't really know if we have these in the right order, RSI to RDI or RDI to RSI, but we'll check our result and make sure it comes out. Okay, so for memcomp, we're going to do this. But RCS X is options. And, well, we need to get the return value. We should actually, okay. Let's put an incomplete here. I was just reminded that I have this. And we can use that here instead of grabbing 8 bytes off the stack. That'll be better. But let's do what we're doing right now, which is we need to take the value of this. So the result goes where? Status flags. Status flags and E flags according to the results. I don't know if I know how to read E flags. After the comparison, okay, so this is like advancing the pointers, which we don't care about. take some, oh geez. If we rep comp SB, is it going to compare every byte? Like we need to like loop comp SB instead? Comment in, oh. Okay. Rep comp SB will compare strings. All right, so the result goes into E flags somewhere. So I guess we just do like, we could just do a jump if equal or whatever. Like we want to somehow turn the status flags into -1, 0, or 1, right? So we could do like a jump if greater, jump less. That sounds a little bit inefficient. I don't know if there's a trick for getting an integer value out of the compare flag. Is there a trick for that? You guess this is why there's only -1, 0, and 1. Yeah, maybe. You need to sub. Well, no, because we don't want to modify the memory. I don't know if there is a rep sub. Like rep is like a hard-coded thing in the CPU. So, yeah. Can you set A, set B? Set byte on condition. Right. There's got to be like a spaceship operator version of this, right? This only sets the byte to 1. It only takes one argument, which is like, dude, these are the most useless instructions ever. Oh my God. How am I supposed to get a -1 out of that? What a disaster. Okay, I'm thinking jump if less to a place that does -1. And then set A You know what I'm saying? So you get the 0 or the 1 out of set A, and then you know. Set A1 register, negate set B, add them up. We could do that. The question is whether you would have that or a branch. All right, let's try this. So we already used RSI and RDI. Dude, I'm gonna have to figure out how to encode the. It's just always confusing how the hell you encode this crap. Like, I don't. It's been so long since I've done any of this. Like, how do you encode an RM8? Because I guarantee you I don't have any of these instructions. All right. We're just going to write the pseudocode calls. Okay. Set A. We're going to put one in RSI. We're going to put one in RDI because we're already using those. And then do I have a sub? Oops. Sub 64. Wait, where does sub 64 go? Does that go back into the... I'm going to have to remember all this mod RM byte bullshit. Oh my God. Okay. So I guess we do that, and then we need to put this back into our so-called okay. That's kind of weird how I did this, but okay. R SI maybe? Dude, I don't know. Okay. So we already have sub 64. We need these. Set A, set B. Set A is I don't know. I don't remember what any of this means. Rex plus OF. I don't know if that plus, am I supposed to add these? Dude, I don't. I don't think so. So OF for set A, 9.7. For set B, 9.2. Okay. And then the argument is not an address. The argument is just going to call it op. It's a register. And I'm just going to, I think we just, like, what's the mod RM byte when there's only one operand? In your comment, you might want to note to use rep e repeat equal. It's F3. The same as rep. On different processors, it might be different. I don't think that's how it works. If it's the same byte, then it's the same thing. There's no such thing as like different things that are the same byte. That's not. Okay. I need to get focus on what I don't understand, which is what the hell goes in this byte. And this is like the nightmare of x64 where everything is Byzantine and totally effed up. Okay. Okay. Instruction, operand, encoding. Op is M. I don't remember what that actually means. And yeah, okay, so I don't even want to read this article. This is so annoying. Let me look. I just want the official manual. I don't want anyone's editorial about this. Okay. So, first of all, I hate all of this so much. It's so ridiculous. Okay. So we're not trying to get to the higher registers at all. So if mod is 3, which is what I usually use, then so RM is just the register index. Yeah, I think this is right. We're going to have to break in some disassembly when this doesn't work, but I think this is right. I don't know, man. Op2 undeclared identifier. I don't frickin' know. I mean, I could just put it in both times for safety's sake. How would a CPU architecture designed by me look like? I don't know. I'm not a CPU person, but like, it's so hard to deal with very basic things in x64 just because it's backward compatibility all the way to the 8086. When they had no idea they would be doing any of the things that they do today. It just makes everything hard to think about and annoying. I believe you just put 0 in the RX field. Yeah, that makes sense. It's just, I don't, like, there's several things going on, right? There's like, what's the bit field in the instruction? There's like, what my little abstraction function that I was calling there, like which arguments are what in that. Yeah, I don't know. It's been like literally 2 years since I touched that. Maybe more. But that's why it's good. It's good to be working on it right now because you warm it back up. All right. So we generated some x64 code. We're not calling it yet. Let's call it and watch our program crash. There we go. Okay, well, it actually mostly worked. Our memsets worked. Our memcpy worked. I mean, maybe it copied more bytes and didn't happen to crash, but it at least copied the right number of bytes. Our compare did not work. So that part is broken. Who knows why? Maybe it's our result getting, because that was weird. But this is very positive because our program didn't crash with like an illegal instruction exception, so that's great. We're kind of there. Have I seen the SO link GCC uses setz? What is setz? Setz for what? We're doing 5 different things here. Can we see the disassembly? Yeah. First, before we look at the disassembly, let's do a couple of things. I just want to fix this weird thing before it lives on very long. So, okay, so wait. This is size in bytes, so size equals 1. We're going to go move extend indirect. I'll put rx rsp size. What is register signed return? A bool. Is it signed? No. All right. So let's just make sure our memset still works. Okay, great. That's taken care of. Okay, so before we look at the disassembly for this, which may well be wrong for all I know, I just want to check this return value thing. So let's how do I move a literal? Here we go. We're just going to go 42 into RSI. And so we're going to test this return value by putting 42 in it. So if our memcomps always return 42, then that part at least works. They do. Okay. So it's really, that's good. So it's really just this part that's in question now. So I guess we'll look at the disassembly. The thing is, it might be a little bit messy because we're going to be looking at disassembly for like a bunch of crap. Because it's like a debug executable and stuff. What is the best thing to do? Let's put at the top of main a really obvious memcomp call. That way we don't have to search around for it. So we're just making some global symbols. And So we're going to have some other stuff that happens for stack marshalling when we enter main, but relatively soon after that, we'll have this memcomp. All right. How do I like just open an executable? Can I do that from here? Actually, I don't even know which menu it is. Let's try dragging the thing. foo.exe. They have to be opened via the file menu. File. Okay, that didn't work. How do I debug a frickin' executable in Visual Studio? You always do it in the command line. Open it as a solution. Okay. All right. Why the drag and drop can't do that, I don't know. So we're going to want to step into... I don't remember how to do that. All right, that just ran the whole damn thing. Step into. All right. Well, we didn't want to go there. We want to go... Oh, you know what? We rename main... What do we rename main as right now? Can't frickin' search the compiler because I closed that solution. Let's open it again. Do we call it double_ main? Generated main. Okay, so I don't even know if we're going to have symbols. We do. Okay, so here we go. And I should have put it in a different function so we wouldn't have to do the generated main thing. That's going to go away eventually. It's just an annoying thing we do for interoperating with C right now. So if we view disassembly, how do I do that? Go to disassembly. All right. This is all stack stuff. This is our stuff there. Okay, so this move ECX, 5 looks suspicious. That doesn't look right at all. And then we do rep e comp s. I guess that thinks it's a signed comp. We really want an unsigned comp. Set A AL, set B AL. So those are not the right registers. So that must be, I probably put the 0 in the wrong argument. So 0 probably means register A. So I think, okay, let's start fixing things. I think we're going to do this and see if that fixes that. I want an unsigned comp. Oh wait, the comp S, the S means string. All right, this is unsigned, right? Didn't we read this documentation and it said it's... I'm not finding the word signed or unsigned here. Do I have to read the status flags differently to think if it was a signed or unsigned? I don't know, man. Yeah, comp S is compare string, totally. Set A, set B cannot work with RSI and RDI. The output need to be a 1-byte register. Is that true? That could be true. Well, I mean, no, because we're using rex w. Oh, wait, no, sorry. I'm looking at the wrong thing. Set. So what's the asterisk here? The operand size is fixed at 8 bits. Use a rex prefix to enable uniform addressing to additional byte registers. Okay, so this means, like, if you use rex R or whatever, you can get to the other 8 registers, which implies I should be able to use it at RSI and RDI. We're just gonna try our register swap and see what happens. Hey, look, it worked. Except they're back. No, it didn't totally work because one of these should be 0 and the other one should be -1. Or AD should be -1 and CD should be 0. So something wasn't good. But this actually is kind of reasonable output. Until doc only says RM8 are valid operands, which are just bytes. Right. I mean, you can only store into the bottom byte of the word, but the fact that they let you put in a rex prefix means that you should be able to address any register, because that's what that's for, right? Scroll up. No, what are you talking about? Scroll up. What are you talking about? Does comp S have a rex W with A6? No, it doesn't. That's a good point. All right. You know, there's no real reason right now to try and use those registers anyway. So for the sake of just being very clear, let's not do it. Okay. So we're going to set A to RAX and RC. I don't know why we're avoiding B, whatever, we always do. Sub 64. See, I want a sub 8. I don't have a sub 8. We're just going to 0 these and then set A them. Yeah. So we're going to 0 them and then do our 64-bit subtract. This is all goofy, but we do the optimized version later. We're doing the working version. Just on the previous run, you had correct numbers. No, you might, it seems to me like you might be getting confused about this, which is the compile time result, and this, which is the runtime result. Okay? These are different. In fact, now that the compile time result is working, we're going to not call that at compile time anymore. Just to reduce the number of outputs and confuse people less. Okay, so there. So now we're getting zeros, which frickin' could be anything. Let's look here again. That ECX comma 5 looks bad. Okay, we're clearing EX. We're set A, AL, set B, CL. Okay. So these are actually right. Problem is, these XORs probably clear the flag from rep comp S. God damn it. Why do we always avoid B? Anyway, we're going to do this. Okay. Lazy and do a sub 64. Later this can be sub 8. Okay. Who knows what's going on? Maybe because RBX is non-volatile for the Windows ABI. Yeah, but that just means we store it and restore it, I think. I hope. Maybe not. Okay, well, we're still not getting the right result. Oh, wait, did we even successfully? No, we couldn't open foo.exe because we were compiling it. There. Okay, so now we've got 1 and -1 again, which is not great. We XOR, we rep E comp S, we set A, we set B. We could actually step through this, but I'm concerned about this ECX thing. Oh, immediate. Why did I do that? This should be indirect. RCX options. I mean, that's not actually going to matter. It's not going to fix anything except for things. It's not going to fix our symptoms. It's going to give us one less problem. Whoops. Oh wait, it fixed. That's weird. We're just in the wrong order, I think. I think we want our subtract to go the other way. Is our dx also non-volatile? I don't know. Okay. Well, same for memcpy, that also has an immediate. Yeah, I just pasted the wrong thing in here. All of these should be that because we don't actually know the size of the thing, so we're reading it out of memory. All right. Takes so long to compile. Okay, I'm sure there's bugs in this, but I have an appointment in a while, so we're going to start thinking about winding the stream down. It's good we established a concrete thing. Maybe try n-1 for bounds check in the memset memcpy. Oh, like, right. That makes sense. In fact, let's put a known byte at the end. Let's do that. That's a good idea. So, a n-1 is, I don't know, AA, right? B, C, and D. So we're just going to put a known byte there. And then, so we're always going to print all n bytes. We're going to memset the -1 so that we leave the AA at the end. We'll leave full n on the memcomps for now. All right, so we've got our AAs. Actually, we could compare to n-1, and we can make this one be BB, and it still should compare to 0. Right, compare CD is 0, even though these differ in the last byte, because we compared bytes -1. Just switch the set A, set B registers, then your sub and the output can start as it was. Does that really simplify anything? Let me see. Yeah, I mean, I like it better if the output's in RAX. It's a good point. I mean, later we're actually going to do, like, the reason we're using hard-coded registers for everything here is because we, like, don't even have a register allocator in this backend. Eventually we will, and then it won't, like, matter, but for now, I just like it better if it's in A. Should we try to do a sub 8 so that we don't do this 0? Let's take a look. Okay. Search is sometimes subtract. Oh, we could use a hard-coded. This is like how silly how far back in time these instructions go, right? It's just like subtract from A was like the actual original instruction. Oh my God. All right. We could use that though. Subtract an immediate from A. Oh my God. Okay. Which one of these do we use? We want an 8-bit sub with non-immediate. Like, I don't understand the difference between, oh, it's, okay, you could put the memory offset on either side, I guess. We're not going to use a memory offset, so it doesn't matter. So we're going to use this. So we're going to say, we're going to get rid of these. We're going to go sub 8. Do we even... We're just going to call them the full, we don't care. Okay, sub 64. Okay, sub 8 is going to be, I guess we could do the Rex later, but for now, we're going to go RM8, R8. Okay. I think 28, I think we just do that. I don't know. I don't know. Let's see what comes out. Okay. It gave us a different result of the opposite sign. I mean, I could do 2A to reverse. There's so many different ways I could reverse this. I mean, but I want the one that takes the operands in the same order as my sub 64, so as not to be confusing. Oh, now it didn't. Okay, whatever. Now wait, we're getting an 8-bit result. It's probably like underflowing or something is what's happening. Okay, wait. No, because we would see those in the E flags. What? When an immediate value is used, it is sign extended to the length. Sub-instruction performs integer subtraction and evaluates the result for both signed and unsigned integer and sets the OF and CF flags to indicate an overflow in the signed or unsigned result. See, okay, we want a 16-bit result, not an 8-bit. This is not really going to be a lot better. Well, see. No, you know what? I don't care this much about instruction fiddling. This doesn't really work for us. Because it's like we want to subtract two 8-byte values and get a 16-byte result that doesn't like, or sorry, two 8-bit values, get a 16-bit result that doesn't over or underflow, and I'm not sure that we get that capability. So I'm just going to put it back at this for now. And we'll get tweaky about instructions later, I think. Unless somebody has an idea. Sign extending is the key here for sub 8. Yeah. I mean, we could sign extend. We could sign extend A and B. Well, these are supposed to be, these are both either 0 or 1. So we could actually put zeros into AH and DH. I don't even know if you can write the DH. Is that a thing? But that's not that much different from this. Anyway, like that's just a level of tweakiness that I don't care about right now. So we might as well zero the whole register. So if we did this, then we could do a 16-bit subtract and it would be fine. It's good. I don't really care. Sub 8 gives you the correct S8 result. Does it though? Maybe it does. But I'm feeling like break time. Like we can do another stream later where we rat hole on that. I'm not that, the reason I'm not that worried about it is that like this whole backend right now just does 64-bit operations on frickin' everything because we don't care right now. And so caring a lot for this one is like a little bit weird until we go through the whole backend and like start, you know, being more picky about like the sizes of the operands and all that. 255 was the -1 I wanted. Right. Okay. So the sub 8. So it puts the byte there, And then we're moving the whole thing. So we would have to do sub 8 and then sign extend, right? I suppose we could try that. But it's a little bit weird because, yeah. I mean, I'm actually not sure right now. The thing that I'm not sure about with the sub 8 is it treating the arguments as signed or unsigned? And the answer, I guess, is in terms of the actual bit output, it maybe doesn't matter because it's identical, right? Is that true? I'll try it. Let's try it just because. Okay. So we're going to do this. We're going back to this. We're going back to this. Let's just get to where we had our 255. Because I don't remember if I needed to swap the operands again. 255. All right. So here we're going to go move extend indirect offset size it's signed and into memory. Does not take 7 arguments. Output offset. Oh no, we don't have. Yeah, I don't. See, we don't have this set up. Oh boy. We could do that now. A direction flag. So we have this direction flag where we use the same function for going into and out of memory. And so this gets set to either 0 or 2, and then that gets XOR'd. Are these the same instructions? No, like I would have to like look up to do this sign extension here. I would like have to look up what the right places are for the direction flag, and I'm too tired for that because I'm jet lagged. So we could do a sign extend in place, right? From like AL into AX. I don't exactly know how to do that. Let's see if we can figure out how to do that. Try memcomp DA n -1. That's a good point. Move SX. Okay. We're just going to make extend 8 to 64. Just hard-coded. And we're going to go rexw fbe and then the mod rm byte. And so we use 3, right? Op. We're just doing this straight in place. Oh, and then out here, right. Okay, we would like to have done the sign extend there, but we didn't. All right. Well, we totally broke everything. Let's see what the disassembly is. I mean, that looks right. Does that not work? Is that not valid? Are you not entertained? Can you not sign extend into your own register? Okay, hold on. Because these values are so weird. If we don't do this, do we get our 255 back or what? Yeah, move indirect is backwards, someone says. Oh, into memory. That's what I didn't do. Okay, that's our 255. So if we sign extend that, great, it doesn't do anything. All right. Okay, so now someone was saying, let's do comp DA as well as comp AD. Well, that is what we expect. So, I think it's Miller time, honestly. You don't know what op order that was, but the store versus the extension were backwards? No. No, 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 no. What? What do you mean? Oh, you mean the, you meant this? Yeah, this was backwards before. That's why we weren't getting our return value. This is correct, right? Right? We all on the same page? How many hours do I code most days? I don't know. Some days 0. Some days infinity. Yeah. Awesome. I saw Abner on the stream. Is Abner still on the stream? What's going on? Maybe not. Anyway, so these are now in the compiler, which is good. It'll improve program performance as soon as we can use them, which is not yet because they need to go into the LLVM backend. But that'll happen before too long. Any final on-topic questions about what we did today? We spent about 3 hours. It took a little long because I'm jet lagged, but we added the concept of intrinsics to the compiler. For now, they're just very basic intrinsics for these things like memset, memcpy, and all that. But that'll expand to other forms of things. And, you know, we just have this simple syntax. The function resolution and all this stuff just uses the same as the rest of the compiler does. So you could use named arguments and all that. But instead of going to a procedure call, of course, this goes to a special compiler hook for a fast thing. Now you could do math intrinsics. Yes, we could. Yes, we could. We could have a cosine that explicitly says use the cosine instruction or whatever. I'm not sure to what extent we want to do that. We need to think about whether that's the right approach for math instructions. I'm not sure. It's a little bit unclear. Just a high-level explanation of how a memset intrinsic would be faster than a method call. Because a call implies all sorts of overhead, and an intrinsic is a small number of machine language instructions. What happens if I go out of business? Then everything is terrible. All right, everybody. Thanks for coming by. We'll do more programming streams again sometime now that I'm back from vacation. We might even do one later today. Again, I'm still on Asia time a little bit, or my body is just really confused about what time it is. So we'll see. Let's see if there's anyone to science and technologize.